Hi, and welcome to this session titled Unleash MongoDB Atlas with Azure. I'm Paul Leury, Senior Partner Solutions Architect at MongoDB, and I'm joined by Azim Uddin, Principal Cloud Solutions Architect at Microsoft. MongoDB and Microsoft have built a strong partnership with the goal of ensuring our technologies work well together seamlessly. This partnership is all about putting developers first, making it easy for you, the developer, to leverage the strengths of both platforms. In this session, we'll walk through how MongoDB Atlas integrates with Microsoft Cloud Services, particularly Azure and Fabric, and how these integrations can enhance our AI-powered applications. We'll also take a deeper dive and closer look at Microsoft Fabric, focusing on how the new mirroring feature can help streamline your data management. So let's get started by exploring these key integrations and how they can improve your development process. As you can see from this slide, our partnership with Microsoft has really been growing over the past few years. We've been busy making sure that MongoDB Atlas integrates seamlessly with a wide range of Microsoft technologies. From using Azure OpenAI for advanced AI features to speeding up prototyping with GitHub Copilot and tightening security with Azure Private Link and KeyVault, we're focused on giving developers and enterprises the tools they need to get the job done. These integrations were all about helping you build and scale your applications with more flexibility, security, and efficiency. And this is just the beginning. There's a lot more in the works as we keep expanding our collaboration. Now I'll hand it over to Azim to dive deeper into these integrations and show how they can power your AI and data-driven projects. Azim, take it away.
Hello, everyone. This is Azim Uddin. I'm a Principal Cloud Solution Architect in Microsoft, and I'm going to walk you through on some of the most common integrations between MongoDB Atlas Cluster and Microsoft Cloud Platform. We'll start with Power Platform. It is one of those best-kept secrets. A lot of folks may not know that Power Apps and Power Automate integrate with MongoDB Atlas. For those of you who aren't very familiar with Power Apps and Power Automate, Power Apps is a low-code, no-code solution for building custom applications. It allows you to quickly build your application UI layer using drag and drop. Power Automate helps in automating workflows and tasks. Both Power Apps and Power Automate connect nicely with MongoDB Atlas via connectors and Atlas Data API. In fact, there is a nice GitHub sample which shows all of these in action with a customer onboarding scenario. If you search on MongoDB Atlas and Power Platform integration, you can easily find it. We have made a lot of progress in developer tools integration. If you are using Visual Studio Code, I would highly recommend you to download MongoDB extension for VS Code. Those of you who have used SQL Server Management Studio, you'll have a very similar experience with MongoDB extension. You can explore your databases and collections, write your queries to explore data, use playgrounds, and you can export these queries and results. You can also access the MongoDB shell from the VS Code, and you can manage or configure your Atlas resources using Terraform. For those of you who use C# language for your application development and use Entity Framework Core, you'll be happy to know that MongoDB Atlas now integrates with Entity Framework Core, which was actually announced in this year's .local New York. This makes it possible for you to use Entity Framework Core from your C# .NET application, connecting to MongoDB, and continue to use your preferred APIs and design patterns. If you are using GitHub today, I'm hoping you have heard of the GitHub Copilot, which is the world's most widely adopted AI developer tool or pair programmer. Not only does it help you write code faster with coding suggestions and creating code for you, it also helps creating test cases and debug your code. Semantic Kernel provides native support for MongoDB Atlas Vector Search. With this integration, users can bring the power of large language models to their proprietary data securely and build generative AI applications using Retrieval Augmented Generation or RAG with programming languages such as Python and C#. As you know, Synapse was Microsoft's one of the primary analytics solutions before Microsoft Fabric was released, and a lot of work was done on Synapse and MongoDB Atlas integration that is still available if you are using Azure Synapse today. There are two modes to connect. For your batch mode use case, we have the source and sink connectors available. And if you have a near real-time use case, then you can use the MongoDB Spark connector or Atlas triggers in conjunction with Azure Functions. Azure Databricks, alongside Microsoft Fabric, is one of Microsoft's primary analytics solutions. So if you are using Azure Databricks in your organization, then we have got you covered as well. We have MongoDB Spark connector that supports both batch as well as real-time bidirectional synchronization of data between Atlas and Azure Databricks cluster. In batch mode, you can use the Spark dataset and dataframe APIs to process data at a specified time interval. For near real-time use cases, the connector supports streaming mode via Spark structured streaming to process data as soon as it's available. Power BI is very popular among the MongoDB Atlas customers, naturally so, because this allows users to leverage operational data in MongoDB Atlas in Power BI and then generate insights and powerful dashboards within seconds. Atlas SQL interface with the ODBC driver is the preferred way of connecting to MongoDB Atlas from Power BI, but depending on your scenarios, there are a few other options available, such as the legacy BI connector. Also, with the Power BI now being part of the Microsoft Fabric experiences, you have the option of bringing MongoDB Atlas data to Fabric OneLake and use Direct Lake reporting mode in Power BI. This is super critical for our enterprise customers, specifically the ones in the regulated industries. All dedicated Atlas on Azure clusters are deployed in their own VNet. For network security controls, you have the options of IP access list, VNet peering, or private endpoint. Using private link with the private endpoint is the recommended option to connect your workload VNet to Atlas cluster VNet. And this is unidirectional connection such that Atlas VNet cannot initiate a connection back to your workload VNet, which is secure. Instead of hard-coding your sensitive information such as MongoDB connection strings or credentials directly in your application code or config files, you can store them securely in Azure KeyVault, which significantly improves the security posture of your application. Azure KeyVault integration also allows you to store your customer managed keys used for encrypting your data at rest in Atlas cluster. In addition, you can also use Microsoft Entra ID for your authentication and authorization needs with MongoDB Atlas cluster for your end users and applications. This enables your applications access to MongoDB Atlas cluster using external programmatic identities such as Azure Service Principal and Azure Managed Identities. Microsoft Purview provides a unified data governance solution to help manage and govern your on-premises, multi-cloud, and SaaS data. You can easily create a holistic, up-to-date map of your data landscape with automated data discovery, sensitive data classification, and end-to-end data lineage. The great news is that you can manage governance for your MongoDB Atlas via Microsoft Purview. All you need to do is to install a self-hosted integration runtime to connect.
Thank you, Azim. Thank you. Now that Azim has covered the integrations, let's focus on this slide as it's especially important because it highlights how systems operate today in the realm of real-time intelligence. So gone are the days when businesses could rely on analyzing data from a dashboard and making decisions like pricing adjustments after the fact. Today, the demand is for real-time decision-making. On the left side of the slide, you'll see MongoDB Atlas, which this represents the transactional system, the engine that feeds into the analytical system. And on the right, we have Microsoft Fabric, the analytical platform that works in conjunction with Atlas. So together, these systems create a loop of real-time intelligence, enabling actionable insights that can immediately be applied back into the transactional system. MongoDB Atlas offers much more than just document storage and retrieval. We are a developer data platform with built-in features such as vector search, full-text Atlas search, native time series collections, analytical nodes, and for real-time insights. These advanced capabilities enable us to handle more complex workloads and integrate seamlessly with Microsoft Fabric for real-time decision-making. So this synergy between MongoDB and Fabric allows for data to flow in real time between transactional and analytical systems. So for example, in our demo today, you'll see a dynamic pricing update that occurs in real time, and it's instantly reflected for users. This showcases the flexibility and power of the document model and highlights how real-time data can enhance decision-making and the end-user experience. So this slide shows how MongoDB Atlas on Azure integrates with Microsoft Fabric. There are two main connection points that we're focused on here. The first one, which came out last year, is a source and sync setup that uses pipelines to batch data transfers between Atlas and Fabric. It's been a solid solution for managing transactional and analytical workloads together, making it easier to move data efficiently between the two systems. Now, the second connection point, which is the one we're really excited about to announce and demo at Ignite this fall, is the new mirroring feature. This will allow real-time syncing between MongoDB Atlas and Microsoft Fabric, so data flows seamlessly between both platforms in real time. It's a game changer for making sure your transactional data is instantly available for analysis, and this will be the big focus of our demo today. This slide represents a high-level architecture for this dynamic pricing demo we'll be showcasing in this video. To walk you through the process, we'll begin by simulating website activity where users are searching for products, adding items to their cart, and making purchases. This website activity is then pushed into the operational data store within MongoDB Atlas. From there, leveraging the new mirroring capability, this data will be mirrored in near real time to OneLake within Microsoft Fabric. Once the data is in OneLake, it is processed by an AI-powered dynamic pricing model, which we developed specifically for this use case. The model will analyze the website activity and generate adjusted prices, which are then pushed back to the operational data store in Atlas. These adjusted prices will then be served back to the retail website, ensuring real-time pricing updates for the end user. So here's our retail website. We have a number of items. We have some handbags here, and we'll pick a handbag, we'll generate some product events. These events will be stored in Atlas, then mirror to Fabric, and we'll go look and see that mirroring process and dive in and then go explore the AI model that'll be run against that data. So we'll select a handbag, and this will generate a view. Then the next event that we would like to generate would be adding it to the cart. So we'll add it to the cart, and then now that it's added to the cart, we will then instantiate a purchase, we're checking out, and now we've just created a purchase. We purchased the handbag. So if we go to Atlas, our database, and we're using here a tool called Compass. It's built by MongoDB. You can download it on the website. I highly encourage you to use it. It's a great UI to explore your databases. And here we have a number of databases, and then the specific one is search, and we're going to focus on this collection here, which is the C-Logs collection. So this collection is where the events that we generated are stored. You see a number of them there. And what we're going to do is just filter on the product that we're interested in. And there we have the three events that we generated for that product. We have the view, we have the purchase, and the cart. And so now let's go over to the Fabric side and take a look at that information in Fabric and see how it's represented there and how we're managing the mirroring. So here we have our workspace. We're in Fabric. There's a number of other items in my workspace. The one we'll focus on is our mirror database. So you see that over there. It's a mirror database. We'll go into the mirror database and explore it. And in that, so what we've chosen to do, you can see here, there's only 4 collections. So we only needed 4 collections for our model to be able to generate the adjusted pricing. And this is all we're needing to leverage. So we'll quickly query our C-Logs to see how many of them are in our Fabric side. And we have about 5,500. And then we'll go and let's go pull up the 3 events that we're interested in, just so we can relate to them. They're fresh. And there they are. So you can see that we have those 3 events. And I'd like to focus on the counts. So we're able to do some inserts and be able to mirror on inserts. And let's now demonstrate the ability to do an update. So what we'll do is we'll go back here to Compass. Let's just change one of these data items on the view. Instead of 1, we'll make it a 2. We'll hit the update, and now information will trigger an event. That information will then get pushed in the Fabric, and that update will get pushed in the Fabric. So if we go and refresh, and here we have that now the number is 2. So we've been able to have inserts mirror and then updates mirror. And what's interesting with this data too, with a mirror database, is you can leverage it all across Fabric. One of the things that I did here is I generated a report. So you have a report here that you can leverage, and a very simple one. I just did website event types, view, cart, and purchase. You can see the distribution. We roughly have about 1,700 views, 700 purchases, and about almost 800 cart. And so we can see some abandoned carts in our data. So now let's go explore what it takes for this model that is going to be making these pricing decisions. So this is a Spark notebook. We won't go into detail in the notebook, just wanted to bring it to your attention that the art of the possible, we can generate these notebooks in Fabric, and it's using data. So the data, in order for the notebook to use the data, what we did is we created a lakehouse, and you can create a shortcut in that lakehouse into the mirror database that we created to synchronize with Atlas. So this is the data, and these are the records that we're leveraging in our notebook to extract the information to then train and allow us to build our model. So then, what's new information comes in random against our model to make those pricing decisions. So just focus here on our, just where we're actually creating the model. So we're leveraging MLflow, specifically the random forest progressor algorithm. And this is in on the data science area of Fabric. And if we scroll down just a little bit, calling your attention to where we're actually running. So we're running the experiment and then essentially generating the model. And then now that model is available to us, we can then go ahead and instantiate it. So the next notebook that we'll explore is where it's actually called. So the first part of this notebook is where we're actually extracting the information. So now data has been discovered, new data has been discovered. We trigger this notebook, and over here is where we'll actually instantiate and call that our model, and then it generates the information that we then leverage to make the according price adjustment. So we'll go take a quick peek at the actual model interface. So there's a model. You can see the versioning that can occur. You can have different versions, and then the different mechanisms to be able to apply those versions. You can do them through a wizard or copy the code. Very intuitive to use, and you'll see the different ML model parameters. So there's a way of being able to inspect and work with your model and be able to deploy different versions. So what we'll do here is the next step is let's go through a batch of data. We're going to generate a lot of activity. So we did a bit of activity on that product, but to really to stimulate it, to get a pricing change to occur, we're going to push some information and generate a lot of traffic around that product that we originally selected. So we've run our batch, and let's go quickly explore in Fabric. We'll just go look at the data and run it against our C logs, and you can see that we have 55. If we run this again, we have a significant amount more records that have been pushed to, and now let's see what effect that those records had on the price. So we're at 345. If we refresh our website, our page, we should see a price change. And yes, we see an upward price, a price increase generated by the AI model. Thank you for watching today's session. We hope this demonstration has provided valuable insights into how MongoDB Atlas and Microsoft Fabric can work together to deliver real-time dynamic solutions like the retail dynamic pricing engine we showcased. In addition to the integrations we discussed today, there are many other ways MongoDB and Microsoft are working together to support modern applications, such as through Azure OpenAI, Power BI, and more. These integrations are designed to give you the tools you need to build intelligent, secure, and scalable solutions for your business. Thank you for taking the time to watch this session. We hope you found it valuable and gained useful insights into how MongoDB Atlas, Microsoft Fabric, and Azure can enhance your applications.